welcome to Developing Faster on Kubernetes. We're going to show you how to use Google Container Tools in Cloud Build. So let's get started.
So I'm David Gageot. I'm a developer advocate based out of Paris, France. And I love everything that's related to developer experience, and I love cats, and there's no connection between the two. And you can reach me on Twitter and GitHub.
Hey everyone, my name is Priya Wadhwa. I'm a software engineer on GCP. I work on a bunch of different open source tools like Skaffold, Canico, and Minikube. And that's my GitHub and Twitter if anyone's interested.
OK.
So let's talk about what it's like to be a developer in Kubernetes, working on Kubernetes. Who here already develops on Kubernetes? Raise your hands. And who is interested in developing on Kubernetes? OK, cool. We're going to talk more about what that's like and making your workflows a bit faster.
Do you like it? Being a developer in the Kubernetes world? OK, because this is our opinion.
Yeah.
Our opinion is that,
Yeah, Kubernetes is really cool, and you can deploy some awesome applications, but sometimes the process of developing on Kubernetes can be time-consuming and difficult, so we're going to talk about making it a bit easier. So let's talk about what a typical workflow deploying to Kubernetes might look like. So I have this really simple Go application which just prints out hello world every second. So I want to deploy this application to Kubernetes, and I'm going to start by making sure that it works as I expect with a simple Go run. So it looks pretty good, and at this point, I need to containerize my Go application so that I can deploy it to Kubernetes later. So I have this Docker file, and I'm going to build my container with a Docker build. Cool. And at this point, I would normally push my image, but I'm using a local cluster, so I don't have to. And to deploy this container to Kubernetes, I have this pod spec, and I can deploy to Kubernetes with the kubectl apply command. So we have our pod created. We can take a look at our logs, and they look pretty good. It's what I expect.
Yeah, it's deployed.
It's deployed. But what if I want to make a change to my application? I want to say something else. So the first thing I'm going to need to do is go back into my main.go file and make my change. So maybe you want to say hello next instead. So I need to rebuild my image now. But this time I'm going to tag with a v2 tag so that we can version control our containers. And then I would push my image, and the next thing I need to do is patch my YAML file.
That's a super interesting job, right? Patching YAML files.
And then reapply my new pod.yaml spec. And if we check the logs, it looks pretty good. So
that's a lot of commands that you typed.
That was a lot of commands, and basically this whole process is what me and David call the infinite loop of pain and suffering. Even the smallest code change requires a ton of commands in my terminal. I have to rebuild my image, remember to tag it differently, push my image, patch my YAML with the new tag, run a kubectl apply, and then verify that the changes I made are actually what I wanted to see. And any error at any point in the cycle can result in me having to go back and debug and spend a lot of time trying to fix whatever I went wrong. So people often solve this issue with bash scripts and makefiles, and they'll automate parts of this cycle away. But is there an even easier way?
I hope there is. OK, so the first tool we're going to talk about is Skaffold. Skaffold is a CLI open source tool that you can find on GitHub under the Google Container Tools organization. And you can just download it and get started. And it gives you iterative development for Kubernetes, whether you're working with a local or a remote cluster. It works on any cloud provider, any instance of Kubernetes. And I said it's open source. So how do you use Skaffold? So I'm sorry to tell you that before you can use Skaffold, you have to write more YAML files. Are you OK with that? Because if you don't like YAML files, don't touch Kubernetes, OK? But Skaffold makes it easy for us to not write this YAML file. we have a command called Skaffold init that will try to introspect my sources, and we'll find the Docker files and the YAML manifest, and we'll try to match them so that I've got a scaffold.yaml pre-generated for me. So it lists one artifact, it lists the YAML file that Priya showed you. I'm going to say, yeah, I think it's the right configuration. So now that I have this configuration with my sources, I can do nice commands such as, not that, such as scaffold build. Scaffold build, not really interesting. It's just doing part of the cycle that Priya showed you. It's going to build your images. This time there's only one image. It's going to tag it. That's interesting because you don't have to think about the tag. Remember when Priya switched to V1, from V1 to V2? Because she knew she changed something, Skaffold will do it for you based on Git tags. But you can do something more interesting. You can do scaffold run. Scaffold run will build your image, will tag your images, will take the tag, put them in the YAML, and send it to Kubernetes, which is quite nice. But you can also do scaffold run --tail, and this time it does the whole cycle in one command. It will show you the logs of all the containers that were built and deployed by Skaffold. So this is the full cycle that Priya showed you with only one command.
Awesome.
Awesome. Who wants to try Skaffold already? A few people? OK. We're going to try to have more. Because you're developers. You told us you were developers. So we're going to do Skaffold Dev, which is just for you. It's exactly the same, but it will also watch for file changes, so that when you change something in any of your artifacts, it will rebuild that image and redeploy what needs to be deployed. Let me show that to you. I'm going to open a new tab, and I'm going to change my code. OK. Typo. Double typo. I'm going to save it, and boom, Skaffold detects that, rebuild my image, retag, change the YAML, redeploy, gives me the updated logs. OK? So to sum up, you just concentrate on your code. You don't have to think about that whole cycle, all the commands. You can forget about them, just learn one command, Skaffold Dev. So who wants to try Skaffold on Monday when they're back to work? OK? Yeah? A bit more. OK, cool. But there's one problem. We showed you that you change something, and it's very quick to rebuild. But in real life, building a Docker image doesn't take 2 seconds, right? Who has Docker builds that take more than 10 seconds or 30 seconds? OK. It can be very, very long. I took a Java example here to show you the problem if you don't know it. So who's a Java developer here? OK. Same problem applies to Python or Node or whatever. It's always faster to build your applications locally on your machine than with Docker containers. So here's a Java application. So usually, to build it, you would run such command. Because it was built already on my machine, it takes only a few seconds to build. I can build it 2 times, it takes 2 seconds. OK? Now I've got a Docker file. I want to containerize my application. So I've got a Docker file which is already quite complicated to write. There's quite a few tricks in that Docker file to make it nice with you. And I'm gonna build my application. It's going to be very quick because I built it already on my machine. But now I'm going to change something in the code. I'm going to change a comment. Oops, where am I? I'm going to change just a comment here, OK? How long do you think it will take to rebuild the Docker image? 10 seconds? 1 minute? 2 minutes? 4 minutes? OK. The thing is that it's going to re-download all the dependencies from my project, all the plugins. OK? So it's going to take maybe 4 minutes on a slow connection, and it's going to be more than that on a very slow connection. So this is the problem with Docker builds. It has a smart caching mechanism, but it will never be as quick as what you have on your machine. Because here, I changed something in the POM YAML. It has no impact on what's on my artifact, on my built artifact, but it has an impact on Docker caching. So it has to re-download all the plugins, which is really not nice. Just that for a Hello World application. So we're going to show you a second open source tool called Jib. Jib stands for Java Image Builder. It's open source. You can also find it on GitHub, same org, Google Container Tools. It's a Maven and Gradle plugin and that you can use to build Docker images without even installing Docker. without writing a Docker file, without learning the Dockerfile syntax. And it gives you fast incremental builds. So I think the Java developers in the room will really like it. All you have to do is add a new plugin to your Java configuration. Just that. You select this Jeep plugin. It's the same application, OK? And now I'm going to run a slightly different command. I'm going to do a Maven compile Jeep build and give it the name of the image that it should produce. And with that command, it will build my application. And when it's done, it's going to produce a Docker image and push it in 4 seconds. I can change the comment in the YAML if you want and rebuild. It should also be about 4 seconds. Because everything was already built on my machine, it's using the cache that's on my machine. It's not using the Docker cache. So maybe you think that's not very important, but when you're using Skaffold dev and you change something and you focus on your code, you don't want the rebuild to take a few minutes. You want it to be as quick as possible. Jeep is one solution. There's other solutions that we won't talk about, but just know that there are people who try to make it very quick for you so that you can focus on your code. One last thing I wanted to say is that Skaffold and Jeep is not just for Hello Worlds. It works very well with a Hello World sample, but here we have a much bigger project. It's a multi-microservices application based on 6 microservices. Each of them has a Docker image, and each of them is in a separate directory. And we have more YAML manifest, YAML, that we want to deploy, OK? And because I've got this Skaffold YAML, I can run Skaffold dev, and it's going to rebuild all my images. It's going to tag them. It's going to put all the tags in the YAML files, deploy everything, show me the logs for all the containers at once. See, it's deployed, and I can see the logs. That's nice, right? So it's not just for Hello World. And if I change something, because I'm in dev mode, like, for example, I will change some Java application, some Java code. I'm going to change the title here. It's the Google Cloud Quiz for next 19. Save it, and boom, Skaffold will detect that, will run Jeep build, and redeploy this application for me. So it deployed only what's needed, and boom, my application is there. I have a very quick feedback. And if I change something like a static web page, it can be even faster. I'm going to add some exclamation marks because I like them. Boom, it's already deployed. OK? Let me do that for you again because it was too quick. OK, save. Boom. Skaffold synced the file from my machine to the running pod on a remote cluster. I don't even have to rebuild the images. So it's really as quick as if I was working locally. So you really get the 10x velocity with Skaffold. So this is a schema just to explain what Skaffold did. So you had all these components, the UI, the title, the game, the database, etc., all of them in different folders. Skaffold watched the sources for all those components. And for some components, it will sync the files to the remote cluster. For some components, it will run Jeep build to make sure that the Java application is rebuilt on your machine. And for the rest, it will do Docker build, which will be a little bit slower, but still very, very nice. And all the ports for all the containers are port forwarded locally on my machine, so that if I connect to remote cluster, like I'm going to connect on GKE, which is a cluster with more nodes. Nope. OK. I can run the same Skaffold dev command, and this time it needs to push the images remotely. But most of them were already pushed, and Skaffold knows that. It's got a very smart, aggressive caching mechanism that Priya developed. So it's the reason why it's so quick. But some of the images are changed in front of you, so they need to be rebuilt and pushed. And when it's done, I will be able to connect to my remote cluster the same way as I was connecting on the local cluster. It's almost there. Yeah. So I'm connected on localhost, but in fact, I'm connected to my remote cluster thanks to port forwarding. And I've got the exact same experience. If I change something Here, more exclamation marks. It's going to be synced like automatically. Was it? Yeah, I think it was. No, maybe not. There's a bug. OK, it happens. That's Skaffold.
That's Skaffold. David just talked about using Jib to make your builds a little bit faster. Skaffold also supports using Bazel. And so you can build locally with Docker, you can build on the cloud with Google Cloud Build, or you can build your images on a Kubernetes cluster with Canico. We also support testing with container structure tests and deploying your application with kubectl, Kustomize, or Helm. So if you use any of these tools already in your Kubernetes application development workflow, you can just keep using them. As long as you put that stuff into your Skaffold YAML, Skaffold will be smart enough to know to deploy or build with the tools you're already using.
Yeah, this is very important for the Skaffold team, that you keep the tools you like Helm or Kustomize or kubectl, and they are integrated in Skaffold so that you can just focus on the code. And it works with any Kubernetes cluster. GKE, any cloud provider, on-prem, local, Docker desktop, Minikube. It's very important. If you have a hybrid setup or on-prem setup, it works very well too. So it gives us very tight feedback loop, and you should try it on Monday, like Monday, OK?
Cool. So David showed us how to use Skaffold as a CLI tool, but can it be even easier? And yes, it can. One of the teams at Google just released Cloud Code, which is an IDE extension that runs Skaffold for you directly from your IDE. So it basically does everything we just showed. Skaffold runs Skaffold Dev, but from the comfort of IntelliJ or VS Code if you use either of those.
Who's using VS Code here? IntelliJ? OK, so all the room. Awesome. Almost.
Cool. So let's do a quick demo. So I have this really retro game of tic-tac-toe, and it's not very colorful. So let's make it a little bit prettier. So
deployed it on GKE, right? Yeah.
Yeah, deployed on GKE. So it's pretty simple, just 2 microservices. I have a tic-tac-toe front end written in JavaScript and a colors microservice written in Go. And basically, this file tells the application what colors I want my X's and O's to be for tic-tac-toe. So if I want to change the colors and make them a little bit more interesting, what's your favorite color, David?
I don't know, blue.
Blue. I already did that one. OK, we're going to go purple.
Blue, OK.
So with Cloud Code, so you saw I just made some changes to my IDE. And with Cloud Code, I don't even have to leave the IDE to deploy these changes to my cluster. So you can see that with Cloud Code, I can deploy, I can create a new GKE cluster, I can run a continuous deploy, which is basically just the Skaffold dev loop that David was just showing. Every time I save a file in my IDE, it'll rebuild my image and push it to my cluster again. So for now, I'm just going to deploy my application to my cluster. And the cool thing about Cloud Code is if I have different profiles, I can choose to only deploy a certain part of my application. So I know I only changed the colors microservice, so I'm only going to redeploy that piece. And
you don't have to do it, but it's nice to have profiles to tweak your build process or deploy process.
Yeah, we can take a look at the Skaffold YAML, actually, and what that looks like. But I have just a simple Skaffold YAML here with my 2 microservices and paths to the Docker files for those images, and then a profile for my colors microservice, which will only build and deploy that bit, and then one for my front end as well. And if we take a look at our Cloud Code logs, we basically just did a Skaffold run again, except this time directly from our IDE, and we went through the same process that we've already been through, except Cloud Code is really nice, and it'll tell me when my deployment has rolled out and is successfully deployed. So if we head back over to our game, we can see we have some colors. So it was super easy. It never had to leave my IDE, and it also told me when it was finished, which was really cool. So Cloud Code also has some fun other things. It does Skaffold YAML validation. So if I wanted to add an artifact here, say I have a third microservice which does something, except this one is built with Bazel. So I can start typing in Bazel, and Cloud Code will autofill the rest of the YAML for me, and I just have to put in my Bazel target. It also will do some validation. So if I put in an integer here, which it doesn't expect, it'll let me know. And if I hover over different pieces of my Skaffold YAML, it'll tell me what those pieces mean and what Skaffold is expecting, which is just really nice during my development process.
Yeah, Cloud Code gives you this validation and documentation on Skaffold YAML, but any YAML manifest for Kubernetes, so your deployments, pods, etc., you have the online documentation and validation.
Exactly. So it just makes Kubernetes development a little bit easier, because I always have to go and look up what a pod spec is meant to look like before I write a new one. Cool. Yeah, so with Cloud Code for VS Code, continuous deployment, you can still run your Skaffold run and Skaffold dev, except this time just with a button click from your IDE, YAML manifest validation, and more. So you could download that today as well.
Yeah.
And then Cloud Code for IntelliJ as well, very similar. But basically, it'll just run Skaffold for you, and you can keep focusing on writing your code, which is the best part.
OK, so we showed how to develop locally, whether it's on the command line or using your favorite IDE. But at some point, your application will get bigger, and you want to be able to build on the cloud. Because building on your machine has its limits, especially if you have lots of microservices. You don't want to build all of them in sequence locally. So we're going to talk about one of the managed services we have on Google Cloud, which is Cloud Build. Cloud Build is a fully managed CI/CD product that gives you extremely fast builds that you can use to automate your deployments. So you can build Docker images or any binaries. You can run your tests. You can run your integration tests. You can deploy at the end of your build pipeline. So you should really take a look at Cloud Build, and we're going to show you how to use it. So usually, to use Cloud Build, you end up submitting a Cloud Build YAML through the command line or through the UI. This is a typical command that you would run. gcloud build submit, and you give it a Cloud Build YAML. And this is the content of the Cloud Build YAML. This is a list of steps that are going to run on your code. So Cloud Build will clone your repo and will run Docker images steps on your code base. For example, here, this first step will run npm install on your sources. And then npm run test to make sure that the unit tests are run. And then it will do a Docker build to make sure to produce a Docker image, and this Docker image will be pushed by Cloud Build. So if I run this command from my sources, it will send my sources and run all those commands so that at the end, I've got a Docker image that was not built on my machine, but built on the cloud. OK? But it's even easier if you're using Skaffold. I just wanted to show you a few UIs, but Priya is going to show it later on. So with Skaffold, it's even easier. Here's my small hexagon example with all the artifacts. And I added a small profile, just 4 lines. And with this profile, you can just say, OK, if this profile is activated, you will not build locally on your machine using Docker, but you will build remotely on the cloud, all the artifacts in parallel. Let me show that to you. I'm going to just switch back to Docker. OK, so I'm going to do a Skaffold build, not using this profile, just to show you that it's building locally using Docker, and all the artifacts were already built, so Skaffold is very quick to tell you that. And I'm going to now activate the Cloud Build profile. So now, this time, Skaffold should send the sources to Cloud Build and compile all the artifacts on the cloud. But because it's smart, thanks to Priya code, it's going to find that all those images already exist remotely. Some of them exist with a different tag, so it's just going to retag them. It's not even going to send the sources to Cloud Build. That's nice, right? So you can really build very quickly. But I'm going to change something. I'm going to change, I don't know, the UI here, exclamation marks. I told you I want exclamation marks. I'm going to Cloud Build, Skaffold build with the profile. This time, one of the artifacts does not exist remotely in my registry. So Skaffold will take the sources, put them in a tarball, send it to Cloud Build, trigger a Cloud Build run, which will then run some commands on top of it. Basically, we'll do a Docker build and a Docker push at the end. And it will be very quick. And it's even quicker when you have lots of artifacts to be rebuilt, because it's going to build them in parallel. And when it's done, Skaffold will tell me. So you see, you don't even have to learn the Cloud Build CLI or API or UI. you can use the same tool, Skaffold, or your Cloud Code extension, and you're going to build on the cloud, which is quite nice, right?
And you don't have to write that cloud build YAML.
Yeah, you don't have to learn it. One less YAML file.
Yeah. That's the dream.
Yeah, that's the dream. Kill them all. OK, Cloud Build with Skaffold. So it builds all the artifacts in parallel. It has very aggressive smart caching mechanism so that any image that was already built and pushed, even with a different tag, you don't have to go through the whole build process, and you don't have to add an additional YAML file. Okay, you should really try Cloud Build. It's very efficient for that, but there's also lots of additional use cases that you might want to explore. For example?
Cool. So David just talked about how we can use Skaffold and Cloud Build together to build our images remotely on the cloud while doing local development. But we can also use Cloud Build and Skaffold together to create a continuous deployment pipeline, which will push your application to your Kubernetes cluster for you. So let's talk about what this would look like. Say you're a developer and your code lives on GitHub and you want to create and you want to add a new feature to your code base. So the first thing you're going to do is develop locally, hopefully with Skaffold now, and get your feature up and running. And then push those changes to GitHub, and as soon as they're merged to master, that's where our pipeline will come in. So Google Cloud Build we're going to use a Google Cloud build trigger to watch your repo, and it'll know whenever you've merged a new change into your code base. And once it sees that you have, it'll pick up your new code base and run a Skaffold run on the code base, and that'll redeploy your new feature to your cluster, at which point you can visualize whatever changes you made as you normally would. So this is the pipeline configuration. We have another Cloud Build YAML, but this is basically what Cloud Build is going to run on every code change. So the first step is pretty simple. It'll just get credentials for the cluster that you want to deploy your application to. And then the second step is just a Skaffold run, which we've done a bunch of times now. So it'll rebuild your images, push them, and then redeploy your application for you.
I just want to say something that's very important. We showed you can use Skaffold on your machine, but you can use it on Cloud Build or any CI/CD system. Because since you've listed all the artifacts you want to build, since you've listed how you want to deploy them, you can do that from Jenkins or anywhere for that matter. So really, this is what Priya is showing you. She's going to run Skaffold from Cloud Build instead of what we've shown where we run Cloud Build from Skaffold, which is OK.
You can do it any way you want, in whatever combination. But let's do a quick demo of how this works. So I'm going to go back to my colors and change them again. Except this time, let's say we're pushing to a production environment instead of a staging environment. So I'm going to want a version control and not just deploy my changes directly from my IDE. So I'm going to commit these changes to GitHub. David, does it look good to you? Code review.
Sorry?
I'm going to say yes. I'm just going to push to master.
Yeah, I like the color, so you can push.
Cool. So now that I've pushed to master, at this point, Google Cloud Build should pick up the change in my code base and start a new build. So we should check the UI. And looks like a build has already started. And it'll basically run the 2 steps that I already showed in the pipeline configuration. So the first step gets credentials for my cluster. And the second step will do a Skaffold run. And I've actually set up my build triggers so that they only run when certain files in GitHub are changed. So this build trigger runs when only my colors microservice is changed, and it'll only rebuild that part of the application just to speed up my deploy a little bit.
So you were in your IDE, you just git pushed, and you've got a whole CI/CD chain that is triggered. It will build all the artifacts. It will redeploy everything to the production cluster, right?
Exactly.
Cool.
And if we take a look at the logs, we've downloaded our Skaffold image, and now we're rebuilding the image.
In reality, you don't have to look at the logs, right? Okay.
Yeah, you don't actually have to. It will just happen. And we're pushing.
Yeah, pushing.
And we should be done soon. Usually this takes around a minute.
Yeah.
And it's done, so if we head back to our application, we should see that the colors have changed. So that is a really simple example using Cloud Build and Skaffold together to create a continuous deployment pipeline.
Sometimes it's so quick that it feels slow. You don't have to do anything. You just git push. It's deployed, but it's.
And then it happens. Sit around.
Yeah.
Get a cup of coffee.
Okay. So a quick recap of what we've seen. So we've seen different ways to develop faster with Kubernetes. All of them are connected to Skaffold, which is the tool we are working on, and that's used underneath by Cloud Code. So Skaffold gives you a very tight feedback loop. Whether you're working locally on a local cluster or remotely, it can work on any type of Kubernetes cluster. And we've seen Jib. Jib is one of the tools you can use to build your Docker images quicker and more easily, because you don't have to learn the Dockerfile syntax, you don't have to install Docker. It will just use your standard build tool to build Docker images. Yeah.
Cool. We looked at Cloud Code, which lets you run Skaffold directly from your IDE. So you just have to hit some buttons, and it'll do all the work for you, which is really nice. And then we also looked at Cloud Build, which can build your images remotely on the cloud, and also help you set up a full CD pipeline for your Kubernetes application.
Okay. So that's about it.